Hello, Jennings Geniuses. Today we're going to be working with subtracting across zero. We're going to review palindromes, and we're going to do something similar to as we did with palindromes and addition. We're going to do something similar with subtraction. But first I want to show you my early birthday present. When all this started happening, my daughter got on her computer when she saw me flipping out, and she researched free resources for teachers and signed me up for a webcam and noise canceling headphones and microphone. Ha ha ha. So I got my birthday present a few days early. So we're going to start with an exit slip. Remember, you're here to do the math and not watch the math. So let's read the problem together and figure out what you're trying to do. Remember, we got to understand, plan, solve, check. And then I want you to pause the video and solve. So let's read through so we understand. Clock A chimes every 2 minutes. Clock B chimes every 5 minutes. If the clocks are started at the same time, how many times will they chime in 10 minutes? So what do we know about clock A? It chimes every 2 minutes. And what do we know about clock B? It chimes every 5 minutes. And how long are we going to let our clocks go? We're going to start them at the same time. We're going to let them go for 10 minutes. And so you're finding the total number of chimes. Pause the video and remember, you have to show how you know. All right, let's look at the solution to that. We knew that clock A chimed every 2 minutes and clock B chimed every 10. So you could have worked it out in several ways. I just went ahead and figured clock A, I'm going to let it chime until it gets to 10 minutes. 2, 4, and each one of these is a chime. 6, 8, 10. And then clock B was only chiming every 5 minutes. So this one chimed 5 and 10. So my total number of chimes was 1, 2, 3, 4, 5, 6, 7 chimes. Give yourself a pat on the back if you got it. Good job. All right, let's move on to our lesson now. You should have paper and pencil in front of you, and you should be working along with me. That's why I'm not giving you a ton of homework, because I'm assuming, Jennings Genius, that you're working along with me. All right, first thing I want to do is just think a little bit more about subtracting across zero. I know we've done a lot of this, but I just want to make sure you remember it and you understand how it works. So, as you recall, I had started a jelly bean business and I had hired some helpers to pack the jelly beans. I had hired Olivia, I had hired Tarun, I hired Helen, and then I ran out of employees, so I had to hire a chipmunk, and his name is Theodore. So now I've got people to pack my jelly beans. Olivia is going to be in charge of the single jelly beans. Tarun will be in charge of packs of 10. Helen's going to be in charge of packages of 100. And now Theodore, the chipmunk, is going to be in charge of boxes of 1,000. So we're ready to go. We're ready to take our first order. So today, when we got ready for our first order, all the jelly beans we had on hand were 2 boxes of 1,000, and then we had 3 loose jelly beans. That's all we had. We had 2,003 jelly beans. So everybody write that down. We're going to write 2,003. That's what we have on hand. Now we're going to have to take an order. So the first order that came in was an order for 128. So go ahead and write 128, because if we're packing them up to sell, they're going to be going away. So you should have written minus 128. Well, we know from our practice last week that we've got a problem because Olivia is supposed to pack 8 single jelly beans and she only has 3. No problem. She asked Tarun, Tarun, may I have a box of 10 jelly beans? I need to pack this order. And Tarun says, I don't have any boxes. I'll ask Helen. So he asked Helen, Helen, do you have a bag of 100 that I could use because Olivia needs some jelly beans? And she says, no, Tarun, I don't have any bags of 100. I'll have to ask that new kid who looks like a chipmunk. So she says, Theodore, do you have some jelly beans I can borrow? Olivia can't pack her order. And Theodore says, yes, I will give you a box of 1,000. So he gives that to Helen. And you remember I hired Helen to work this position because she's such a fast counter. So before we can do anything with real life, we've got to record what already happened. Theodore no longer has 2,000 jelly beans. He has 1,000 jelly beans. Helen had no jelly beans. He gave her 1,000 jelly beans. And we're writing a 10 here because this is the hundreds column and 10 hundreds is 1,000. But this doesn't do Helen any good because she only deals with hundreds. So she dumps out the jelly beans and super fast, she packages them up in bags of 10. So now she's got 10 bags of 10 jelly beans. She's ready to give Tarun his jelly beans. She says, Tarun, I know you just wanted 10, but I don't have 10. I'll give you a bag of 100. So, bam, she gives Tarun a bag of 100. If we did that in real life, we have to do it on paper. So, Helen no longer has 1,000 jelly beans. She has 900 jelly beans. Tarun no longer has 0 jelly beans. He has 10 tens. So we put a 10 there because 10 tens is 100. This still doesn't help Olivia. So Olivia says, Tarun, are you ready to give me those jelly beans? And he said, hold on 1 second. I got to do some counting. So he dumps out the bag of 100 jelly beans and he packs them up so super fast into 10 boxes of 10. So now he's ready to give her some jelly beans. So he gives her 1 box of 10. Bam. Now, if we did that in real life, we have to do it on paper. So we're going to say he no longer has 100 jelly beans. He has 10, 20, 30, 40, 50, 60, 70, 80, 90 jelly beans. So we're putting the 9 in the tens column, which represents 90. And at last, Olivia has enough jelly beans. She has 1 box of 10. And this is where a lot of kids make a mistake. They're so happy to get to the end of this thing, they just write 10. But we have to remember, she doesn't have 10. She has 10 plus 3 because she already had 3. So we're going to put 13 here. And now we can subtract. I want you to finish solving that. Pause the video and solve. All right, and let's look at this together. 13 minus 8 was 5. And so let's do that in real life. Let's subtract 8. She goes to the bank. She trades 10. She dumps them out and she gets 10 jelly beans. And then we're going to pack up 8 of the jelly beans. So 13 minus 8, she has, whoops, there went one of my jelly beans. She has 5. 90 minus 20, you should have got 70. 900 minus 100 is 800. And then your comma, 1, 2, 3, comma, you know the pattern. 1,000 minus nothing is still 1,000. We understood, we planned, we solved, but we're not finished. You have to check. So, is it reasonable that if you had 2,003 jelly beans and you subtracted 128, that you could end up with 1,875? And that seems reasonable to me. So good job if you got that. Now we're going to change gears. And we are going to think again about palindromes. That was a long time ago, wasn't it? We learned that if you add, and sorry, the dog's going to start barking. We learned that if you add reversals of numbers, you will end up getting palindromes. Numbers that are the same from front to back and back to front. Like somebody gave us the example. You can do it with words. The word race car is a palindrome. It spells race car this way. It spells race car this way. But we also found out there can be palindromes with numbers. So the first thing I'm going to do is give you a number, 29. What would be the reversal of 29? Everybody write your 29. We're adding. We're getting palindromes. All right. The reversal of 29 is 92. So go ahead and add. Do you get a palindrome? You can pause if you want. 2 plus 9 was 11. I'm going to put my 10 over here. 10 plus 20 is 30 plus 90. That gave us 120. And then we add 100 plus nothing, 100. So there you go. There's your palindrome. It reads 121 that way. It reads the same way in reverse. All right, I'm going to do another one, and I want you to pause the video and solve and see how many steps it takes you to get your palindrome. We're going to start with 45. Everybody write the reversal, pause the video. So the reversal of 45 is 54. 5 plus 4 is 9. 40 plus 50, 90. Still one step to get your palindrome. All right, we're going to do one more palindrome, and then I want to move on to subtraction reversals. So I'm going to give you the number 64. You go ahead and reverse that and solve. If you don't get a palindrome, you have to reverse the next number and continue to solve until you get a palindrome. So pause the video. Okay, when you reverse 64, you got 46. And your brain should have gone ding, 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 because you see a family of 10. 4 plus 6 is 10, so you had to take a 10 over to the tens column. 6 plus 4 is 10. 60 plus 40 is 100. Plus 10 is 110. So you write that. And 110 is not a palindrome. Now this was kind of a tricky one, because if you reversed 110, you got this number. And you should have seen something that looked suspicious to you. And what looks suspicious to you is 0 is a placeholder. You have to have it here so that we know that is 110 and that is 100 instead of 1 and 110. But here you don't need the placeholder. No number starts with 0 except for 0. And when you add, 1 plus nothing's 1, 10 plus 10's 20, 100 plus nothing's 100, and bam, there's your palindrome. It reads the same this way, 121. It reads the same this way. So we found out about palindromes, and if you recall, we worked through one that took something crazy like 7 steps, but we got there, and some of the parents even did the challenge at home and subtracted all those numbers with us. Well, today we're going to talk about something called subtracting reversals. And I'm going to get you to take a picture of your work today and submit it, turn it in. So you should have all this just on a sheet of paper, just like you would have it on a dry erase board in class. All right, let's start out with, pick a number, any number. I'm going to look at my hundreds chart, and let's start out with 47. All right, so here we go. 47. Now, we're subtracting reversals, and we're working with whole numbers. We're not working with negative numbers. We're not working with integers. So, to subtract the reversal, I'm going to get the number 74. So, am I going to do 47 minus 74 if I'm working with only whole numbers, or am I going to do 74 minus 47? Right. I'm going to subtract from the larger. So, let's all do that. 74 minus 47. And pause the video. Okay, we saw we should be world experts at subtracting with regrouping now. We asked ourselves a question, will I need to regroup? And the answer was yes, because you cannot take 7 from 4, but we're not saying there's not enough 1s in 74 to subtract 7. We're just saying they're not available if you're using the algorithm. So we go over, we get 10 more. We don't write 10 here. We write 10 plus 4, so that's 14. Minus 7, your brain should be going ding, 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 because that's a double. And then 6 minus 4, 60 minus 40 is 20. Let's keep going. Let's subtract the reversal. 72 minus 27. Pause the video. Again, you asked yourself, will I need to regroup? And the answer was yes. So we took 10 here. We have 2 plus 10. We have 12. And this is one of my pet facts. 12 minus 7, 5. 6 minus 2, 4. Let's keep going. What's going to happen? Let's figure it out. What's the reversal of 45? It's 54 minus 45. Pause the video and solve. All right, so will I need to regroup? Yes. So there were 40 here, 14. 14 minus 5 is 9. And 40 minus 40 is nothing. I don't write the 0 because it's not needed as a placeholder. And then what's the reversal of 9? Well, it's 9. 9 minus 9, bam. You ended at 0. Now, can we say that when you subtract reversals, you will always go to 0? Can we say that? Definitely. And the answer is no. We've only seen that happen once. What would we have to do in order to say that it's always going to end at 0? Right, we're going to have to do some more examples. So let's take our 100 chart. We're going to do a couple more, and then I'm going to let you do some for homework. Okay, so let's just pick a number, any number. Okay, 23. So we were all going to write 23. What's the reversal of 23? 32. And since that's the greater number, I'm going to subtract from that. Pause and solve. Okay, so there, you did need to regroup, so that's 20. And now it's 10 plus 2, that's 12. 12 minus 3. You should have got 9. What's the reversal of 9? 9. And bam, we got 0 again. And you might be seeing a pattern as well. Think about any pattern you're seeing. And let's do one more. And then you're going to investigate this further with your family. Okay, we're going to pick a number, any number. Okay, 38. Here we go. 38. What's the reversal of 38? 83. And I want you to pause the video and solve, keep subtracting reversals, keep subtracting reversals until you can go no further. All right. Will I need to regroup? Yes. I don't have 80. I have 70. I don't have 3. I have 10 plus 3. I have 13. 13 minus 8 is 5. 70 minus 30 is 40. So I got 45. Now I'm going to do 54 minus 45, which you should have done. Will I need to regroup? Yes. I have 4 10s now. I don't have 4 1s. I have 4 plus 10. I have 14. 14 minus 5, 9. What's the reversal of 9? 9. Bam. We got to 0. So you should be seeing two things happening. We are always ending up on 0 so far. Oh, look at my dirty dry erase hands. We're always ending up on 0. But something is happening before we end up on 0. So your homework is to ask 2 family members to give you any number, any 2-digit number between 11 and 99. And you're going to subtract the reversal and see what happens. And when you photograph your work, I want you to have at least 2 examples of asking a family member, maybe just for fun, tell them to give you a number between 50 and 99. And then you go ahead and work through the subtraction for 2 numbers given to you by a family member. You can call Grandmom if you want and ask her. She'd probably be glad to hear from you. All right. I'll see you next time. Be sure to turn in your work.